And instead of wasting 6 minutes watching Witsit ramble, I'm going to just explain it quickly, then show you why his claims completely collapse the moment we test them. But if you think I'm lying or misrepresenting anything, here's the debate. You can find it on YouTube. It is Debate Austin Witsit Gets It versus Globy McGlobeface podcast on the Modern Day Debates channel, and it was live streamed on February 27th, 2024. So this is Witsit's page here. He's explaining how angular resolution limit makes us think that we're on a globe with a radius of 3959 miles. So we're going to take a look at the formula he used, test the numbers he's plugged in, and watch what happens when we replace his cherry-picked numbers with real, factual, measurable numbers. But I want to start with this little interesting bit.
All right, the angular resolution limit of the human eye is about 1 arc minute, or approximately between 0.02 and 0.03 degrees.
So he said that here. Angular resolution limit, 1 arc minute, 0.02 to 0.03 degrees. 1 arc minute is 0.016667 degrees. So we're already off to a rough start with Witsit being incorrect. And if we look at what the optical resolution of an eye is, it does say 1 arc minute, but here we go. Between 0.016 and 0.02 degrees. But here's the formula Witsit presented. Radius of Earth equals d, which is distance, divided by the tangent of 2 theta. And where does this formula come from? Well, it doesn't appear in anything optics related, anything astronomy related, anything geodesics related, and I wasn't able to find it in any published works myself. It looks like something Witsit or some other flat earther may have just typed up in this documentary and hoped that people would blindly believe him. But let's be generous. If this equation is factual and it works with real physics, it should hold up the second we test it. So back to this page that he was showing, he says that the eye has an angular resolution of 0.0217062 degrees. I don't know where he got this number from, because again, the human eye sees at 0.016 to 0.02 degrees. And then according to his little presentation here, assumed light wavelength of 666 nanometers was used. Here's the light waves. 666 nanometers is pretty much right here at red. But as far as I know, the human eye doesn't only see in one red color, unless there's something I wasn't told about. A quick search says that the wavelengths that we see in is between 400 and 700 nanometers. There's this handy dandy angular resolution calculator. So we do need the aperture diameter of the eyeball, which if we look here is between 2 millimeters and 8 millimeters. We're going to go ahead and use 2 millimeters because most of the time when we're doing long distance observations or looking long distance, we're outside. We don't have 3-mile buildings we're inside of. So we're going to plug in what he said, 666. Our eyeball is 2 millimeters, resolution of 0.023. Again, I don't know where Witsit got this random number from. And then we're going to look down here. Angle represents 6-foot drop from a 6-foot observer. So he's also using a 6-foot observer and saying that the horizon distance is 2.999547 miles away. Now we do know this. Anybody that's been in this conversation for a while knows that the horizon for a 6-foot observer is 3 miles away. It's actually 3 to 3.1 miles. And it's pretty much 3 miles away with 0 refraction, which is absolutely unheard of. And interestingly enough, when Earth's radius was first calculated 2,000 years ago in about 240 BC, the average person was only 5'5" to 5'7". The average man, women 4'11" to 5'3". So again, he just pulled the random 6-foot observer for no reason. It looks like every single number Witsit is using was chosen for a very specific reason, and that's to force the math of his equation here to work. Here's the biggest giveaway that this equation is just made up. This here, tangent 2 theta. Witsit doubles the angular resolution with 2 theta. So it takes his 0.0217, etc. to 0.0434. But in optics or geometry, you don't double diffraction limits. You don't somehow double your viewing angle of anything. No scientific equation uses twice the angular resolution of the eye to determine anything. It's literally something that just doesn't happen. You don't magically see twice the angular resolution because someone writes it on a made-up equation. And this factor of 2 has absolutely 0 justification. Remove the doubling and his math collapses instantly. But we'll keep going to test Witsit's formula. So back to this, we look at between 400 and 700 nanometers in wavelength. And when we look at the angular resolution, 400 is 0.0139 700 nanometers is 0.0244. And what we're going to use for a real one is 0.018, right in between. Now, this is Witsit's equation. We have our horizon at this 2.999547 miles divided by the tangent of 2. And what he's saying the optical resolution of the human eye is gets to 3,958.80, which is exactly what the radius of Earth is. Interestingly enough, using the mile as a measurement wasn't created until about 150 years after Eratosthenes said the Earth was this big in kilometers that he probably used. But that's another beside the point. So this is Witsit's math, assuming that we only see in 666 nanometers of red. And yes, Witsit chose just a red 666 all on his own for his math to work, but also because people are scared of numbers. But looking at this, what if we test indigo and green? So when we plug in indigo, which is 425 nanometers, we get 0.01485. And when we plug that into this handy dandy calculator here, we have Earth's radius has all of a sudden jumped up to 5786. So let's check green at 550 nanometers. So now with green at 550, we have a resolution of 0.01922. Plug that into our calculator here, and Earth's radius has now jumped up to 4,470. And just for shits and giggles, we're gonna use the average angular resolution and get 4,773 radius. So here's what we got. With Witsit, we're getting that with his just randomly chosen 666 nanometers. But if we see anything in indigo, the Earth is substantially larger. If we see anything in green, the Earth is only a little bit larger. And if we see anything in the average human eyes, like resolution, the Earth's radius is 4,773 miles in radius. Now, this is all using Witsit's equation here that he magically wrote out all this stuff to make work. So according to Witsit Gets It, when I'm looking at any color outside of red at 666 nanometers, Earth has now magically changed sizes. Now, I don't think everything that I see past 3 miles is the red of wavelength 666 nanometers, but I could be mistaken. Who knows? Maybe as things get distant, they change to red for me. Now, here's something that destroys his math and model even more. What if the observer's not 6 feet? What if they climbed a mountain, say 1,000 feet high, and looked out over the ocean? And they could see the horizon at 39 miles away. Well, shoot, we can plug that in. 39 miles, that's the distance, divided by tangent 2 times. We're going to use Witsit's angular resolution here. We got 51. That gave us an Earth radius of 51,000 miles. So if somebody's standing on a hill, all of a sudden Earth is massive. So just by changing the colors we look at, or any height outside of a 6-foot observer, Witsit's random formula with his random chosen numbers doesn't work. It doesn't match reality, and it doesn't match real physics. It only matches the fact that he pulled these magic numbers out of flat Earth air to make people believe it. And this is a claim Witsit made during this debate about 5 minutes after that presentation.
Now, what has happened since then is we pulled out binoculars and telescopes and cameras, and you can bring the boat back. Objectively, I've done it hundreds of times.
He's done it hundreds of times, but funny enough, those videos don't exist anywhere. So let me show you what actually happens. I've got the P950 set up. Right now with my eyes, I can see a golf ball that's way down there. Pretty much make out what it is. But when we look through the P950, we don't see it. The ball is too small for the little sensor on this camera to resolve. Now I could easily pretend it's behind the horizon, and when I zoom in, we zoom it back in over the curve of Earth. If it's gonna focus here. And there it is. We have now zoomed this golf ball back in over the curvature of Earth. This isn't magic. It's not zooming things in past the horizon. It's just making it so that the camera sensor can finally resolve it. And this is exactly what flat earthers do. They pretend to bring things back in over the horizon just because the camera sensor can't resolve it, and then they zoom in and it can. This is somebody else's video because I don't live by water, but here's the thing. If the horizon was causing the blur limit of the eyes, then using any magnifications should push the horizon much farther away, except for that it doesn't. Telescopes don't move the horizon, binoculars don't. Zoom cameras, like you just saw in this video clip, didn't all of a sudden make that ship back there appear more. So the only thing that happens when you zoom in is you can resolve more details above the horizon, like the tops of ships and buildings, but the horizon itself stays exactly where it was, still blocking the same amount of the bottom of things, no matter how much you want to zoom in. So here's what we've learned. The formula that Witsit uses is made up. The numbers he chose are very cherry-picked. The angle is doubled for absolutely no reason. The wavelength is chosen one specific red that I'm pretty sure 100% of people on Earth that have vision see more than that one shade of red. The observer height only works for a 6-foot observer when Earth's radius was calculated and people were only 5'6", 5'9". And the horizon distance he used doesn't actually match reality. He had to shorten that a little bit. When we plug in real, factual, measurable numbers, everything seems to fall apart instantly. What Witsit accuses scientists of doing is exactly what he did himself. He reverse engineered the answer he already knew and tried to make it like he discovered some hidden truth. Test the claim, see for yourself. Don't get fooled by people on the internet.